This is the screencast for section 1.5, example 7. We're going to find an inverse function. We're going to show that f of x equals the square root of x plus 3 has an inverse function and find the rule for that inverse function. We're also going to state any restrictions to the domains of both f and the inverse function of f. So let's first find the inverse function. If f of x equals the square root of x plus 3, which also means y equals the square root of x plus 3, the inverse is going to switch x and y. So now x equals the square root of y plus 3. I can square both sides, and now I have x squared equals y plus 3. Subtract 3 from both sides. So now y equals x squared minus 3 is my inverse function. Now it looks like the domain of f is including negative 3 to infinity, and then the range of f, well, since this is a square root function, the range of f is going to be anywhere from 0 to infinity, because if I plug in negative 3, the square root of 0 is 0, and then anything bigger I plug in than negative 3, the square root is going to increase from there. So the range is 0 to infinity. You could also graph that to make sure. Now, this is where it gets weird. The domain of the inverse function looks like it should be all real numbers. But that is not correct. The domain and the range, the domain of the inverse and the range of the original function switch. So the domain of the inverse is in fact 0 to infinity, which then also means the range of the inverse is going to be negative 3 to infinity. Now let's look at that graphically. In my calculator, I'm going to put in y1 the square root of x plus 3, and then in y2 I'm going to put x squared minus 3. Zoom 6. There's the square root function. See, now that doesn't make sense, because the square root function, graphically the inverse shouldn't all of a sudden create a second half to the function. It should just be this piece reflected across the line y equals x. So I have too much graph in the inverse function. That's where the restrictions come in. So I'm going to second insert some parentheses around my y2 function and apply the restrictions from the range of the function. So I'm going to put in parentheses x, second test, is greater than or equal to, we are including 0. Now let's graph and see how that looks. There's the original, there's the inverse function. So now I've verified graphically not only that the function I came up for the inverse is correct, but also the domain of that inverse is also correct, to make sure that the original function and its inverse are just a reflection across the line y equals x. The now try problem is number 17. It wants us to find the inverse formula, or a formula for the inverse of f, and give the domain of the inverse of f. Include any restrictions inherited from f. So we're going to do that. First, y equals the square root of x minus 3. I'm going to switch x and y. Now I'm going to square both sides of the equal sign to get rid of that square root, and then add 3 to both sides. Y equals x squared plus 3. So again, I have this situation where f of x, there we go, where f of x is a square root function, so the domain of f is including positive 3 to infinity. The range of f, so if I plug in positive 3, 3 minus 3 is 0, the square root of 0 is 0. So the range is going to be 0 and up, which means the domain of my inverse is going to be the range of the original function, 0 to infinity, which means then the range of my inverse is the domain of the original, 3 to infinity. And of course, you can verify that graphically on your calculator and apply those restrictions by multiplying your inverse function by x is greater than or equal to 0.